All right, guys, this is going to be the last video for Unit 2. We're looking at how to do these normal calculations with the calculator. So what I've done is I've typed up here at the top, this is all the um, directions for a TI 84, 83, 84. And then I'm going to go through some the TI Nspire. I'm not going to go through all these problems just because it's once you get used to the calculator, it's pretty straightforward. So let's take a look at a couple of these questions here. And I want to note a couple things. So these are the directions at the top. You can read those on your own. Right here, this is going to be the big thing. Okay. To earn full credit on a question involving normal distributions, you must draw a well-labeled picture, and you must also label things lower, upper, etc. Okay. So we're going to talk about like lower bounds, upper bounds, the mean, standard deviation. You got to label everything and draw a picture if you're going to use the calculator. Okay. And this is for the AP test as well. Otherwise, you do not get full credit. So make sure you're doing that thing right here. Make sure you're paying attention to that. Okay. So here the question is: suppose that Clayton Kershaw with the Dodgers was a fastball with a mean of 94, and standard deviation of 2, and the distribution is approximately normal. About what proportion of fastballs would be at least 100 miles per hour? Okay, so that's the question. And on the TI Nspire, let me pull this up. Okay, so you're on your calculator screen if you're on the Nspire. All right, and what you're going to do is you're going to hit menu. There's this button right here for me. Down to statistics, distributions. Okay, and at the top here we have normal PDF and normal CDF. Okay, PDF is when you're looking for a single point. That's easy to remember. P stands for point. So if I'm saying, okay, what's the probability that Clayton Kershaw's fastballs are exactly 96 miles an hour? Okay, you can use this one. For this question, we're looking at the probability that the fastballs go travel at least 100 miles an hour. So that's 100 and above. So we're going to use CDF, which stands for cumulative. Okay. So anything that's involving range, we're going to use the CDF. And once you click, this is pretty straightforward. I'm going to click on this. Now it's asking what's the lower bound. Okay. The lower bound here, we're looking for at least 100. So 100 or above. So 100. The upper bound, okay, just pick some arbitrary big number. Right, 2000. The mean was 94, and the standard deviation was 2. Okay, hit OK, and you can see how nice this is. There you go. There's a probability, 0.001. Okay, so it works out really fast. So now if I go back to the notes, I can type some stuff in here. So I did. If I'm going to do it with a calculator, I've got to draw a picture, right? So if I'm going to do this with a calculator, I got to do a couple of things. So you got to draw pictures. You're going to draw a little distribution, right? You're going to say the mean is 94. 100 is over here, right? You're going to label this all properly, and then you're going to shade in the region that you want, okay? And then you're going to go in, and then you're going to type in what you've done in the calculator. So if you go norm, so you can say norm CDF, that's what it's called in the calculator, okay? And then you can type in what you put. So we did 100 is the lower bound, 2000 was the upper bound, 94 and 2. And then you're just going to label what each one of these things is. So your lower bound, 100, upper bound, 2000, your mean was 94, your standard deviation. So if you're going to use the calculator on a test or a quiz or on the AP exam, you got to have both the picture and this sort of writing where you say, okay, here's what I typed in the calculator, here's what everything means. And so the AP reader knows exactly what you're doing. Okay. Number 2, you guys can practice on your own. I'm going to leave that one for you guys. It's the exact same thing, but just again, read the question. We're going less than 90. So here your upper bound would be 90. Your lower bound would be some arbitrary small number. I'll do C and I'll do D. Okay. So for C, I'm going to go back to the calculator between 93 and 95. Same thing, menu, statistics, distributions, normal CDF. Okay, we want between 93 and 95, so my lower bound is 93, upper bound 95. mean 94, standard deviation 2, hit OK, 38.29%. Okay, so it just spits out the percentages right then and there. So now, again, same issue here, right? When you do this, you gotta draw the picture, label everything. So we went, we did norm CDF, lower bound was 93, upper bound 95, 94, 2. Same thing, lower bound. I'm not going to draw the picture on this one, but you guys can. Okay, and then we can actually write our answer. I think I forgot to write the answer on the last one. And then a little sentence, we could say that P was equal to 0.3829. And then we could say for Clayton Kershaw, the probability that his fastball travels between 93 and 95 miles per hour is 38.29%. Okay. So this would be a full credit solution on the AP exam. Okay, you need to have all this along with the picture. Okay, I'm going to show you another calculator function here. Now we're talking about the percentiles. So remember on the last ones we did this like in reverse. We had to look up the score and it took quite a while. So you're going to see how fast it is on the calculator. So I pull up the calculator again. We have another distribution here. Okay, third one down, inverse normal. Well, what does inverse mean? It's going the opposite direction. So that's where you're going to use this one. Now here, the first thing to ask is area to the left. Okay, when it says area, it's talking about area to the left. So we want the 30th percentile. So we want 0.3. The mean was 94, and the standard deviation was 2. Okay. Now again, make sure you read the question because they'll say the question asked how fast is Clayton Kershaw's fastball is going to be in the upper 20th percentile, upper 20 percentile, right? Then in the area, you'd have to put 0.8, right? It's always area below, okay? But anyway, do this, hit OK, and there's your speed, 92.95. And again, if you go back to the notes, you have the same thing. You have inverse normal, and you type in the area, 0.3, 94, and 2. And then you can label everything. So area to left equals 30%. Mean is 94. Standard deviation equals 2. And then you could say a little sentence, to be in the 30th percentile, the fastball will need to travel 92.95 miles per hour. Okay. So the calculator becomes really, really nice to solve some of these problems. Okay, I'm not going to do letter E. It's pretty much the same thing. I applied some knowledge to a little bit of challenge questions. We can go over this in our live meets. I'm going to skip over that one for right now. I'm also going to skip over F. These are two really good problems that you can do on your own. Try them out, and then we can go over them in class. Okay. And the rest of the problems here are just applications of what we just did. So I'm probably going to skip over all these, and we can kind of go over them together in the live session. But again, don't be afraid to use a calculator at this point. And again, for the 83, 84, your directions I typed up right here. Okay, so you're going to go to distributions, which is second vars, and then you can use normal CDF or inverse norm, and they're all there. Okay, and then you can type in the numbers, and you can kind of see it's all written out for you guys. So that's going to be the end of this video. That's the end of Unit 2. If you guys have any questions, again, please let me know, and I'll see you guys soon.